Welcome back to CS 712. This session's more about DFAs and regular languages. So the theorem we want to look at today is that the language recognized by a DFA is a regular language. Okay, so that any language recognized by a DFA is a regular language. The proof is by deconstructing the DFA to produce regular expressions. So again, you give me the DFA and I'll take the DFA apart and produce the regular expression. And the first step is to take the black box that you've given me. So it's not really a black box. Here's the DFA someone gives me. The first step I do in this algorithm is I add a special start symbol, a special start state at the beginning, connect it to the start state of the original DFA, and I connect all the final states in the original DFA to a new final state that I construct. Okay, and I use lambda arcs to make those connections. And again, there could be multiple final states in the original DFA, and I just draw an arc from all of them out to this new final state that I created. So that's step number one. Another step is anytime that I see a situation like this where I've got two states connected by two different arcs, I can simply combine those arcs together, right? There are two pathways from I to J, so it's equivalent to the regular expression, essentially, X or Y. So this is what we're doing, right? We're going to take the states out and we're going to replace the alphabet symbols on the arcs with regular sets. Okay, so then the goal is to eliminate all the states except for my initial, my newly constructed initial state and my newly constructed final state, and just have an arc, hopefully, from between those two states, and it will contain the irregular expression that was matched by the original machine. Okay, here's the key step, because now we're going to eliminate the original states one at a time. And here's the pattern that we're going to use to eliminate a state. Right, I've got state J in the middle here. And this is sort of the most general way to think about how state J might be lying between two other states, I and K. So it's in the middle here. It's connected by X and Z, which again, as the algorithm proceeds, those are going to be regular sets. Okay, J might have a self loop, again labeled by a regular set Y. And there may be a bypass arc that goes from I directly to K, which again is labeled by yet another state. So we pull J out of there. What can we do? I draw an arc from I to K, and what's the regular expression I want to model this with? Well, it's traverse X, traverse Y as many times as you want, including 0, and then traverse and match Z. That's one way to get to K, or take the bypass route of W. Okay. Now, the important thing is this is a pattern. We have to apply it for every pair of states that are connected via J. So in this case, I've got I connected to K via J, so I'm going to generate this arc. But there may be other pairs of states that pass through J, and we're going to have to process all of those pairs as well, creating other arcs. And in fact, it's possible that there's an arc from K back to I, and some pathway through J from K to I. We'd have to consider that too. Okay, so important thing to remember as you're running the algorithms, you have to consider all pairs of states that are connected via J. Okay. So we do that, we eliminate all the original states, and we end up with one or two cases, right? All the original states are gone, so we only have my original start state S, not the original, the one I created actually, and I have my final state that I created called F, and there's two cases. Either F is connected to F when we get done eliminating everything, in which case the label on that arc will be the regular expression recognized by the original DFA. Second case is we end up, there's no way to get from the state S to the state F, which means there was no way to get from an initial state in the original machine, from the initial state of the original machine to a final state in the original machine. So the original machine had to recognize the empty set in that case, and so that's what we'll say. If I can't connect S to F when I get done with the algorithm, then I say, well, the original machine, only thing it could have recognized was the empty set. Okay, so let me try to run an example here. So if that's my original machine, what am I going to do? Well, the first step is to add the new start state. This is the problem with doing this without an audience. You guys had an audience present, you'd catch me when I make dumb mistakes. Hopefully I don't make any dumb mistakes here. I already sort of made a mistake because I didn't want to draw a double circle there, because that's the original. And this is the new one. So it's sort of screwed up all around here. This is the F. This is the original final. I guess I can recover from that. Everybody sees what I'm doing, right? Here's the original machine. And all I did in the first step is I connected, I'm missing a lambda there, I created a new start state, initial state, connected it to the original initial state. I took the original final state and connected it to my new final state. Okay, now I'm going to run the algorithm and eliminate states. And I guess I'm going to do eliminate the original states one at a time. So the first step here is to eliminate that state. So this is a pretty straightforward case. I'm just going to concatenate what's on those two arcs. So I've got state S here. I'm leaving all the rest of this the same. This is going to draw it now. Well, I did it again, didn't I? Just when I said I wasn't going to do it. Okay, so that's supposed to be all the same. I'm missing a back arc here, aren't I? It's going to be a miracle if I get through this without making a major mistake. Okay, how's that look? I've got B, I get the B, the A, the B, original final state, new final state. Now, I've tried to eliminate that state. So I'm going to replace that state and concatenate those two arcs. And I concatenate the lambda and the A, and that's just A. Okay. So a lot of students, they see this sort of thing, they say, well, why did I create the initial state? Well, this is a simple example, so I didn't really need to, but believe me, on more complicated things, it's useful to introduce that start state and that final state. Okay, I forgot to draw a circle around this. All right, so I eliminated that one. Let's try to eliminate this one now. So again, I'm over here. The rest of the machine is going to be the same. I guess I'll keep drawing it with double circles at this point. And now I've got to consider all pairs. Well, here's one pair, right, that goes through the state I'm eliminating. So this would be A, B star A. There's no alternative path. So that's what that's going to be, right? A, B star A. But now there's another pair. This node is connected to itself via that. So I'm going to have to represent that with another arc like that. And now it's B star A. So B star A. Okay. But now I've got two arcs that go to the same node, so I can bring those together. So I'm going to go to another sheet of paper, I think, at this point. Let's see if I can do this here. Because now I've got the start state over here. I've got the state B going to the original final state, a lambda arc connecting the original final state to my new final state. And I've got this big arc here that's going to be the same, A, B star, A. And I want to combine these two arcs together, right, with using alternation, of course. So this is still a self loop, but now it's got two cases, B star, A, or A. Okay. All right. All right, let's continue from there now. I'm going to get rid of this state next. So again, it's going to leave me with only the original final state to eliminate after this step. And again, this is a pretty straightforward case, I guess. It's going to be A, B star, A. I better use parentheses. And I've got all this stuff on this self loop. B star, A. I better use nested parentheses, or A star. All right, so A, B star, A, then as many times around this as I want, which was B star, A, or A, and star around that component. And finally, just a B to get there. Okay, so one more step to go, which is just eliminate this lambda arc, which is trivial again in this case. All right, I'm going to just have this arc across here, and now I'm just concatenating the lambda, which of course has no effect. B star, A, or A star B. The lambda concatenated and vanishes. Okay, so S is connected to F, so in fact the label on that arc is the regular language, is the regular set denoting the regular language that was recognized by the original DFA. So again, just an example of how to illustrate how the algorithm, goes from the DFA to the regular set recognized by the DFA. Okay. Let's stop there.